All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing something slightly different. Um, well, we've done this before in the past. We're going to be doing something slightly different compared to what we've been doing for the past month. Let me put it that way. Today we are revisiting Rust on ESP32. Because eventually I was planning on, going back to doing research on Rust for ESP32 and also, doing ESP32 programming and stuff like that. Um, but I was just gonna, give time to the other stuff that I had planned, the other projects that I had going on, uh, the other learning sessions that I was currently involved in. I was going to give time to all of those things and eventually get to ESP32. However, just today I got an idea for a project that I want to work on that is actually a very simple project, which I feel like it's going to be simple yet complicated enough to be slightly challenging for a beginner project for me. So what I had in mind was more of it's sort of a reminder slash to-do list kind of application. Not even an application. It's going to be physical hardware. But like, let me explain the idea behind it, because this exact same thing could very easily be accomplished with a simple TUI based application, but that's not the point. Implementing it as a TUI application is not at all the point. The point is to have physical a physical console, a physical hardware kind of thing that I that catches my attention through some kind of like flashing lights or something like that. Because something that I've noticed is I could create I could create a to-do list, right? I could have I don't know, I could set up like digital reminders in some way. That would get kind of messy, but I could create a to-do list. I could write stuff somewhere and keep it, but then eventually my mind is just gonna get distracted from that. It's gonna move away from that. Just a second. I did not go back to this. Yeah. Okay. Eventually my mind is gonna get distracted from that, or I'm gonna forget about it, and then that list is just kind of um, it's just kind of useless at that point. And I'm also not accomplishing the stuff that I was supposed to be accomplishing. So to kind of combat that problem, the idea that I had was so I have like I've used to do list applications. Uh, I've used a very sophisticated tool like Task Warrior, for example, right? But what I've found is what I mainly need is to have visual indicators, visual reminders, something that's gonna remind me that hey, you're supposed to be doing this thing, right? And I feel like the best way to do that, as weird as this may sound, the best way that I would be able to accomplish this is if I created a very simple cardboard based to-do list board, and next to each task I have like a small LED, and just like that I'll have, I don't know, maybe 6 tasks or 10 tasks or how many ever, like I want to give like a maximum number of tasks. And then I'll have a microcontroller that's blinking those LEDs or turning them on or off, or in a constant blinking state, or rapidly blinking or whatever. Just giving using the LEDs to give visual indicators that yes, this task is remaining, this task has not been completed yet, and stuff like that. I would try to do this using displays. It's just that that would be a little expensive, and doing it with paper is going to be a lot cheaper. The only thing I need to control electronically is the LED lights. I feel like that would scale a lot better for me, as in scale, not as in make the application more complex, scale um, as in make the thing itself bigger. The hardware, the board and stuff, I can make it much bigger and have small lights there. Whereas if I wanted like a bigger display, electronic display, that just becomes more and more expensive. Not to mention it's also going to take up more power. So all of that just seems incredibly unnecessary. Also, this would be really cheap because I have a bunch of ESP32s lying around. Not only do I have regular ESP32s, in the past I've bought ESP32 Super Minis, ESP32C3 Super Minis, and these things are like, dude, I'm not even exaggerating when I tell you these things are like one third of your index finger. That's how small they are. And in terms of width, they would be like two fingers of width, if that at all. That's how small those things are. And you get like maybe, I don't remember, anywhere between 8 to 12 pins. I don't think 12, maybe 8 to 10. And two of those would be going for your VCC and ground, definitely. But then you have a couple of like GPIO pins, and you have certain pins can also be reused for other purposes, like um, different types of serial communication, and some could be used for capacitive touch, some could be used for PWM and stuff like that. Where was I going with this? Yeah, so I have a bunch of LEDs lying around. I have um, a bunch of ESP32s lying around. I have PCBs. I have wires and stuff for setting up a very basic circuit. So I was like, dude, I mean, why not why not set up something using the tools that I have? And that would be a perfect um, that would be like perfect for me to uh, learn Rust programming on ESP32. Like that would be like a great example, a great practice program kind of thing. So we are going to be visiting or revisiting. Well, it's more. It's at this point it's more visiting because like I've learned the basics up until setting things up, as in setting up the tooling, which fortunately in the case of Rust on ESP32, it's relatively simple. It's a relatively simple setup. There are some tools that you have to install. Those tools help you do stuff like I believe there was cargo generate, which helped you generate the project along with the necessary settings within the cargo toml file that you require, just to set up the project so that when you actually when you run the program, or whenever you're trying to flash the program onto your ESP32, then all of those settings and stuff, they all get handled for you. So we're going to revisit all of that stuff. That's what I've learned so far. I didn't really go too deep into the coding side of things. I went as far as turning certain GPIO pins on and off, but that was about it. I didn't really go too deep into that. I was also still pretty new to Rust back then. At this point, I wouldn't say I'm new to Rust, which I'm kind of happy to say that because I've been using Rust a bunch, enough that I'm well versed with at least the basic syntax of it, because I've been using it in like these different avenues, or these different um, applications or situations. I'm not sure what to call it, but I've been using it in like different you know situations. Like there's creative coding, there's data science, and now there's the embedded stuff, and there's like a bunch of stuff in which I've been using Rust. So I'm getting a lot more comfortable with the language. So I'm happy to be able to say that I'm comfortable with the language. Now that being said, um, we are going to be just going over this because I want to set up the tooling, which I'm pretty sure I have it set up already. It's just a matter of revisiting that knowledge and um, remembering exactly what I'm supposed to be doing, how I'm supposed to set up the project, and how I'm supposed to flash the program onto compile and then flash the final program onto the ESP32. And further from that point, it just runs. Um, yeah, yeah. So, one more thing. Um, I just wanted to get this clarification because we are going to be doing no STD based ESP32 programming. No STD Rust basically allows you to do Rust programming on bare metal. It's not using any sort of like standard library features. I cannot remember exactly what the features were that would have been available on the ESP32, but like on the OS, um, on something like Windows or on Linux or something, it gives you a bunch of extra features, stuff like I don't know, file system access and access to like threading and various other like OS specific features. Like you would have those features implemented through the standard library, and the ESP32 version of that has its own set of extra features that it gives you, which if you are not using the standard library, you're going to have to find other ways to do those things or just implement them yourself, right? However, doing STD, it does add an extra layer on top. So if you're trying to avoid that extra layer and really go bare metal, you want to go no STD. And there seems to be quite a lot more support for no STD as opposed to STD, though it's not like, or okay, I could be wrong about this, but like I've seen um, a lot more not support, but a lot more community based projects that are aiming more towards no STD than STD. Give me a second here. So I'm gonna ask this question because I was curious about like what extra features. Actually, I think the documentation here will give us that information. The embedded Rust book, embedded Rust on Espressif. Yeah, okay, this is what we are looking for. And then there's also a book for STD. If you would like to learn about the standard development, about STD development, then see using standard library chapter of so and so. So let's see if this gives us the extra information that we. Oh, okay, yeah. So it seems like a bunch of stuff has moved because I'm getting a bunch of these like redirect kind of messages. Um, Let me try to wait. Hold up. I don't know if this is what I'm looking for. Okay, the documentation seems to be like all over the place right now. Embedded Rust on Espressif training, and then the Rust on ESP. Okay, let's see. So this is what we were looking at, and okay, hardware, tool chain installation. Okay, using ESP generate. So I remember ESP generate. I also remember that later on I started using this ESP config, which is a TUI that allows you to configure a bunch of options through, of course, a TUI before your project gets generated for you, which is actually super useful because that way you don't have to guess flags and the various options that the flags accept. The TUI just gives you the information, and you can choose from that information. Um, Give me a second here while because I'm trying to, dude, all of a sudden, like the stuff seems all over the place. Where is like which book is it that I was looking for? Just a second. Okay, embedded Rust, no STD. This is the Rust on ESP book. Um, this has a bunch of these examples. Okay, to better understand this approach, see developing on bare metal. There is that repo. Maybe the repo has more up-to-date stuff. Okay, so there's no STD, which we have open, and then there's STD as well. Um, videos, okay, templates, tools, okay, okay. Okay, you know what? Instead of looking into this, I'm just gonna ask the question here. Hey, so I'm looking to get back into doing embedded Rust for ESP32. I did a tiny bit of it in the past, just to get an LED blinking. Just a second. So, so there's quite a bit for me to explore. I do know that I want to do no STD, not STD, but I'm having trouble remembering what niceties STD would offer. Okay, let this generate the response. And in the meantime, give me a second while I open up my stream on my phone. Just a second. Also, I noticed something. I don't know if this is a sign that my microphone is slowly dying, or because like this microphone is a couple of years old, and I have used it for quite a while. I've definitely used it for quite a while, and it has served me pretty well. Let me just put it that way. However, I have noticed that over time, I've had to turn up the volume, or get the or amplify the output from the microphone that's coming in, because for some reason it just starts to become lower and lower, and I'm not sure exactly what's going on there. I doubt it's a dust kind of situation. It could be a dust kind of situation, to be fair, but every day after I'm done streaming, I put a plastic bag over the mic, so there isn't a dust kind of situation. There shouldn't be a dust kind of situation. Give me a second. Let me try something. Because I have a pop filter here. Okay, how does it sound right now? Actually, okay, now it sounds way better. Holy shit, now it sounds way better. You know what? It might be my pop filter. Holy shit. It might be my pop filter. I think maybe I need to like try and clean the pop filter in some way, cuz like I can still see through it, so I'm not sure to what extent it's really blocked. But let me see. Let me look into it. Cuz like I've noticed that I had to change the settings in my VTuber app so that my model responds much more the to the mic input, and also in OBS I've had to increase the gain filter. I have a gain filter on this mic. Um, well, I have a gain filter on this mic audio source. Well, okay, so let's read what Gemini is saying. Of course, it's a great question, as understanding what STD provides makes it clearer why and how you operate in a no STD environment. Think of it this way: STD, standard library, assumes you are running on a mature operating system like Linux, Windows, Mac OS. It uses the OS to provide a rich set of features. No STD makes zero assumptions about the underlying hardware or whether an OS is present. You are on your own, but you have full control. Here are the primary niceties that STD offers, which you won't have by default in no STD. Okay, heap allocation, the biggest one. Oh, I completely forgot about this one. Heap allocation is not a thing, so you're going to be working primarily with the stack, which it has its own benefits. Um, and I'm not entirely sure. Oh yeah, no, no, no. The borrow checker thing still comes in because like the owner for something on the stack could still, well, kind of to a certain extent. I think I was about to say that the owner for something on a stack on the stack could still change, but like a lot of times stuff that's on the stack, it implements the copy trait. So like if you try to change the owner, it just copies instead of moving. Though there might also be situations where um, you're borrowing a value, you're borrowing a variable, just so you're not, unnecessarily making a copy of it. And you definitely want to avoid making unnecessary allocations, um, especially on limited resource hardware like the ESP32. Because like on the ESP32, we are talking about KBs, maybe MBs of RAM. There's, it's not like in the GBs like how we have on on computers. So like you have to be incredibly frugal, let's say, with your RAM usage. Incredibly frugal, incredibly economical. Basically, just don't waste RAM. You don't have that luxury on the ESP32. Okay, anyways, carrying on. Heap allocation, the biggest one. The most immediate difference is the lack of easy access to dynamic memory. In STD, you get you get heap allocated collections out of the box, like vector, string, box, hash map. Okay. In no STD, there is no heap by default. You can't just create a vector. You have to either use fixed size data structures that live on the stack like arrays, or you can enable the alloc crate. If you do this, you must provide a global allocator library that knows how to manage the device's RAM. Once you do that, you can use alloc vec and alloc string. I didn't know about that. Okay, that's good to know. That is actually good to know. Then operating system services. STD abstracts over OS provided functionality. Since a microcontroller doesn't have a traditional OS, these are unavailable. So threading, file system, networking. I know for networking, there ESP32 has its own stack, especially for the RF related stuff. Like, and I believe I had read this on stream. I think it was on stream that I had read this. I was doing research on why why Wi-Fi and Bluetooth stuff seem to be slightly complicated on the ESP32, and it turned out that the specific Wi-Fi technology, the specific, not just Wi-Fi technology, the RF technology in general on the ESP32, that specific thing, like the entire ESP32 is open source, right? But that specific technology is not. That specific technology, the the functionality for that is provided as a blob by whatever company, and then the community has had to reverse engineer that that driver or that set of drivers to understand the functionality and then eventually try to replicate it. The good news is that they've done an amazing job of replicating that, and they created their own open source alternative for running all of this RF equipment, be it like Bluetooth stuff um, or Wi-Fi stuff or whatever else. Right? It's not completely perfect. It's not completely bug free, but they're fairly confident that it works the majority of the time. I but yeah, I just remembered that that's something that we had done research on stream. So networking to a certain extent, yes, it is available through other stacks, through other well crates in this case. Standard input output, print line macro. Yeah, that makes sense because it doesn't have anything else. It doesn't have something to output to. Um, in no STD, there's no standard output. You must configure a peripheral like UART yourself, and use a logging library like so and so to send data through it. I should keep in mind that this is an option. File system. I also don't know how you go about doing file system stuff. For threading, for multi-threading, there I do need to check out Embassy. Apparently, that allows you to do async slash multi-threading stuff. I don't know if it's either or both, kind of like Tokyo. I do need to look into that. I haven't looked into RTIC, real time interrupt driven concurrency. Yeah, I haven't even heard of that. But I've definitely heard of Embassy being mentioned a couple of times, even in like higher level projects where people were implementing entire like libraries and crates and stuff, and async came up. They were like, yeah, you can do async through Embassy. Give me a second here. I've been trying to load up Fillion's stream just so I have some background sound, but for some reason, loading up her stream in particular just seems to be not doing so well. Oh, okay, now it's doing well. I think maybe my internet was just having some trouble. Yeah, might have been some internet trouble. Okay, then standard input output. Okay, automatic panic handling. In SCD, your program panics. No, in STD, when your program panics, the standard library has a default routine that unwinds the stack and prints a helpful backtrace to standard error. In no STD, you are required to provide your own panic handler. This function is what the compiler will call when a panic occurs. A common implementation is to print an error message over the serial port and then enter an infinite loop to halt the processor. Okay, all right. I was also doing research on, hold on, to show you guys this thing, I'm gonna have to export this entire conversation. So let's do chat, save. Is it save? It's not save. It's share. Chat, share, Gemini, explains LED ESP, uh, LED ESP32, LED project, let's say, dot MD. Okay, and then I'm gonna open this up in NeoVim. Gemini explains LED. Give me a second here. Okay, let's get rid of that and get rid of that. Oh God, what is, hold on, back up. I unlocked my phone and TikTok was open. And whatever video was playing previously, it started playing. Okay, give me a second while I open up my stream manager. Oh, something else that I've been, um, well, actually, I might kind of rush with setting that up. But yeah, something that I've been meaning to look into is um, oh yeah, something I've been meaning to look into is setting up the webcam, because I already have the webcam set up. I have the webcam even connected to my machine. Yeah, I have the webcam even connected to my machine, and all I have to do is just enable the thing in OBS. I've set the whole thing up. Fortunately, it's a very simple setup. Just plug and play. It works. It's recognized by the OS, and it's being recognized in OBS as well. So I'm able to very easily just get the thing started. I just need to find like a proper place to how do I say this? I need to find a proper place to set up the circuitry and like display the circuitry. It's gonna be a little bit complicated, especially if I'm doing like how do I say this? Like my microphone is currently in front of me, and it's on a platform, a makeshift platform that is hanging off of another platform, and it's being weight balanced basically. So I have the microphone on one end, and I've actually put like a pillowcase with rocks on the other end. Fortunately, I had those rocks lying around from some other decoration kind of thing. But yeah, I'm using that. I'm using it as a weight balancing kind of thing. Um, so that's my mic stand setup that I have right now. I don't have a way to, or I'm gonna have to find a way to somehow fit a webcam setup into this, because the webcam setup is not for my face. It's for showing the electronic components that I'm working with. Um, so yeah, I'm gonna have to see how to go about it, because I could very easily like create a space where the entire, you know, the breadboard and the microcontroller and the various components and all of them are going to be, but then that's going to be kept away from me. It's not going to be near me. So anytime I want to make a change, I'm going to have to either get up and go there and make the change, or bring that thing to me, which means it's going to go off camera so I can make the change and then put it back there. That just doesn't seem that great. So I'm going to have to come up with a different way to set this up. I could try to make like a very limited space kind of thing on this platform itself, where I'm weight balancing my microphone along with those stones. In the center of the platform, I could have like a small uh, deep deep dish kind of tray, and in that tray I can keep the breadboard and whatever other components I want. So that way I would have like a very limited setup there, but it would be a bit of a setup. It would help me get started. I can say that for sure. At least as far as playing around with stuff on breadboards goes, it would help me get started for sure. And I even have like a small, like kind of deep tray kind of thing. It's a very small tray, which seems like just perfect for what we are trying to do here. I might, you know what? I might look into it. I might need to do a bunch of um, testing off stream, but yeah, I could definitely set something up. Okay. Uh, Hold on. Okay, let's yank this all the way to the bottom. And if I try to paste now, this is what comes out. Yeah, okay, all right. That is our, yeah. So I could, actually, I don't even need to paste this. I could send it over. I'll just save this. Because, okay, I was discussing this with Gemini. I was discussing how I would be able to um, set up a microcontroller to control individual LEDs, like let's say 5 to 10 LEDs individually, not all at once. So each of them would have their own states. They don't all blink at the same time or, you know, turn on and off at the same time. They all are for different tasks. So each of them is going to be blinking or on or off at a different time, right? Um, what was I saying? Oh, yeah. So, um, in terms of controlling LEDs from a microcontroller, the best you're able to do with, let's say, a GPIO pin is one LED. You shouldn't be going any more than that because the GPIO pins are not really rated for anything more than that. Give me a second here, dude. I'm looking at this voice level and I'm like, can I do any better with this? Um, okay, can I increase this to like okay, maybe no, you know what? Maybe I shouldn't play with it too much. Oh, you know what? Let's increase this. Yeah, I've increased this by like 6. Check, check, testing. Yep, okay. That's much better now. That is actually much louder. That is so much louder. Actually, that might be too much. Um, that might be too much. Let's turn it down because I have two gain filters on this. That's how much I had to turn it up in the past. Okay, check, check, testing, testing. Hello, hello, check, check, testing, testing. Okay, on OBS, it is great. It's coming in pretty great. And on in my VTuber app, I've had to turn the settings up just so that it amplifies the audio much more. But yeah, okay, I should be coming in a little louder now. I'm gonna see how this sounds in the VOD later on. Hopefully, no, actually, this seems to be a little too much still. I think turning up the gain that much made it a little too sensitive. So let's turn it down. Let's say -7 dB. Okay, check, check, testing, testing. Yeah, okay. I think this is good. I think this is satisfactory. Right. So, what was I saying? Oh, yeah, I was supposed to move this file over using SCP to this location. Okay, okay, okay. All right. Okay. And that should be good. A little more. Okay, for this, we could probably put it here. Just a second. Oh, hey, hello, hello. Olax TTV. Hello, hello. Welcome to the stream. How's it going? Love from India. Thank you very much. Hell yeah, dude. Appreciate it. And thank you for the follow and thanks for the posture check and stretch. Yeah, give me a second. Let me get up and stretch. Okay. All right. So, I've transferred the file. Now I just need to open it up in one of the this is in Ratatouille. Let's go back and go into empty directory. And here, let's open up the thing in Frogmouth. Gemini explains LED project. Okay. So in this case, Gemini's idea was to use a technique called multiplexing or Charlieplexing, and I haven't really gone too deep into the technique yet, but the gist of it was it essentially wanted me to set up like a matrix to make more LEDs addressable using a smaller amount of pins. So this way I would be using much lesser amount of pins than if I were not using this method. So if I was like addressing the each of the LEDs using individual GPIO pins, I would be using much more a higher amount of pins. Um, okay, so this was my prompt. I said, hey, so I do projects with ESP32 a lot. I recently bought USB-C breakout boards to power oh to power microcontrollers, modules, and so on using a phone charger because it has the right voltage. Okay. What I'm wondering is, so okay, my question initially here, it didn't start with powering LEDs. My question here was, would I be able to power multiple ESP32s off of one phone charger? Because one phone charger gives you 5 volts, which is it's great for ESP32. That's exactly what ESP32 needs. But would I be able to power multiple ESP32s using one phone charger? Is the current draw going to be just enough or way too much or what? As it is, I plan on just powering one ESP32 so far because I don't like so far I haven't really set up a second project that absolutely needs to be powered off of the exact same power source. Worst case scenario, worst case scenario, I have PC power supplies lying around, and PC power supplies can they give you three different types of voltages. They give you 12 volts, 5 volts, and 3.3 volts. So I can use the 5 volts pins, the 5 volts wires, and I think they give you a good like, I don't know, anywhere between 2 to 5 or 2 to 10 amps worth of current. So you can be pretty demanding with um with current and even with voltage when it comes to these power supplies. So again, worst case scenario, if I do end up in a situation where I need to power multiple of these devices, if I have multiple ESP32 projects, which might eventually happen, but if I do have multiple ESP32 projects and they all need to be powered at the same time, and I don't want to be connecting multiple phone chargers to it, I can just wire up a power supply and split the connection between all of them. And I can also set up like a fuse in between each of the four connections so nothing can go back and destroy the power supply. Which the power supply itself, it does these power supplies usually have circuitry to handle like fuse or reverse polarity. They have not fuse, short circuit protection. They have short circuit protection. They also have protection for reverse polarity and a couple of other things which would be considered like, very basic circuit protection. But like if it wasn't there, then I would have to implement it myself. So, and I don't know how to implement it because I'm not that great with analog electronics. A lot of the stuff that I've done has been with digital electronics, which also I'm I'm getting very tempted to set up that whole thing that I was talking about yesterday with with asking Gemini to prepare an entire syllabus for me where it teaches me analog and digital electronics, but primarily using microcontrollers. So what I'm going to tell Gemini is, look, here's what I've got. I've got an ESP32. I have a couple of ESP32s. I have a bunch of electronic components like LEDs, transistors, capacitors, resistors, diodes, switches, and a bunch of other stuff, potentiometers, which are variable resistors, and like a couple of these discrete electronic components. I also have breadboards, so I can use them to set up the electronic circuits with these electronic components. Keeping these tools in mind, I'm purposely not going to mention anything about a multimeter because I do have a multimeter, but I want to see to what extent Gemini helps me use the ESP32 as a multimeter or an well as a voltmeter or as an ohm meter or even as a logic analyzer, because Gemini has mentioned that it can help me with all of those. There was one more thing, not just voltage and current and the logic stuff. There was one more thing, something for measuring pulse width modulation. So an oscilloscope. So to a very limited extent, definitely it's going to be a very limited extent because oscilloscopes are like entire computers of them. Those are like entire, dude. When you buy an oscilloscope, there's a reason why those things are so expensive. It's because they have like a whole bunch of functionality built into them. They are like entire computers of their own. And what an oscilloscope can give you, at least on a it with like much more advanced projects, you cannot get that by trying to build an oscilloscope using an ESP32. I understand that, but I'm still very much a beginner, and all of my projects would be considered beginner projects. So I don't think I'm going to get to that point anytime soon. When I do get to that point where trying to use an ESP32 as an oscilloscope is not going to work out that well, then I could look into buying an oscilloscope. But for now, I want to see how far I can get with it. Because if I'm able to finally get to the point in analog electronics where I've always wanted to be, to where I can, very comfortably set up these various circuits and do all the calculations that I want for more complex circuits, not for the simpler circuits. When I'm able to do all of that and I'm happy with where I've gotten, then I'll be satisfied with this whole experiment. And as an added bonus, I will have learned quite a bit, and I will have gotten experience with doing Rust programming on ESP32, which, by the way, we are starting that right now, anyways, right? So I will have gotten a bunch of experience with doing ESP32 programming on, well, Rust programming on ESP32, and just in general, I will have gotten a bunch of Rust experience and also ESP32 experience. Like, holy shit, I've got a lot of ESP32s lying around. I love the fact that these things are so cheap, like incredibly cheap. If I wanted, I could place an order on AliExpress to buy, like, I don't know, 5 of them for super cheap, and I could get them in the next two weeks. I love that because that makes it so this kind of embedded programming is a lot more accessible to not just me but a lot of other people as well. And also just hobby electronics projects, they're a lot more accessible to people without having to buy a bunch of very expensive equipment. Anyways, let's continue with this. I was asking about like how well it would be able to supply the voltage and how well it would be able to supply the current. And this is where like Gemini mentioned that it's very basic electronics principle where you have series and parallel connections. If you're doing a series connection, then the voltage increases, the current remains the same. So the voltage kind of adds up and the current remains the same. But if you're doing a parallel connection, so they're all connected in parallel, all of the pluses are connected together and all of the minuses are connected together, that's a parallel connection. In that connection, the voltage remains the same, but then the current adds up, right? And this is great, but the problem is, at a certain point, you're going to hit the limit of the phone charger. The phone charger can give you usually anywhere between 1 and 2 amps. And if you're not doing something heavy on the ESP32, you should be fine. If you're just powering LEDs take like 20 milliamps usually. So if you've got like, I don't know, 10 of them, you're gonna hit 100 milliamps. That's like zero point 0.1 amp. So you still haven't touched the the limit the of the phone charger. So you should be fine. But if you're using other functionality within the ESP32, like any of the radio frequency functionality, like Bluetooth or Wi-Fi or something, then it starts to pull a lot more current, and then the current requirement is going to increase. So then if you have like 2 or 3 ESP32s, you're looking at easily 1.5, 2 amps, and that can eventually become bad for the phone charger. Or the charger is just not going to provide enough, and then the ESP32 is going to start to malfunction. So that was answered here. And then I asked the question over here. So let's, I said, okay, let's talking about, no, I meant, okay, let's talk about a project I have in mind involving just one ESP32. Now, let's say I have an ESP32 C3 Super Mini. These devices are incredibly small, which is great, but that also means you get around 1/3 the amount of pins that a regular sized ESP32 would have. So if I wanted to control, say, 10 LEDs independently, what are my options there? Because I know there are multiple approaches that can be taken here. For sure, trying to power multiple LEDs off of one pin all at the same time is a horrible idea because the current draw would be more than the pin is rated for. But really, what are my options? I'm assuming that an LED I'm assuming there are LED controller modules. I know for sure there are LED controller modules. I just wanted to see what Gemini would say. Um, yeah, I know. I'm assuming there are LED controller modules that you get for this purpose. I would like to explore that option too. But yeah, what are my options and what are some clever ways to go about setting something like this up? Now, there are a couple of solutions that Gemini gave. Actually, there were four solutions. One of them was multiplexing or charlieplexing, which is a method that I decided to go with. Um, Another method was using something called a shift register, where you can give it like bit patterns and it does the addressing accordingly. Another method was, um, wait, yeah, okay. Um, Another method was to use an LED controller module like this one, dedicated LED driver ICs. I'm assuming even the power for these ICs would be external. Like you would probably have to power the module separately, kind of like you have how you have DC and servo driver modules, where give you have to give them power separately. You can't just pull power from the ESP32. But that's an option as well. I don't have that option. I do have something that kind of resembles that, but like it's not what I'm looking for. Actually, no, hold on. I was planning on using that for something else, but then now I'm probably not going to be using it for that. I was planning on using it for that, but now I'm probably not going to be using it for that. Keeping that in mind, what if I could modify that circuit? Because that circuit, okay, the circuit that I'm talking about is, just a second here. Okay. What was I saying? Yeah, so the circuit that I'm talking about, this thing is this is an RGB LED strip, and it's one of those ready-made ones that you get that you can uh, you have like a remote control with a couple of like preset colors and preset modes. So you hit a specific button, and then there's a LED LED driver IC that controls the entire LED strip, and the entire strip is RGB lights, so it sends different combinations of voltages to each of the RGB pins to control the color. Now the thing is, you control the entire strip's color at once. You don't control like different. You don't have like different. What do you call it? You're not controlling different chunks of them differently. You're controlling the entire strip at once, but you can have a custom color. You can have a custom color, but it would have to be for the entire strip. What I need to see is if there is a way to modify that same circuit to control multiple chunks of LED, strips. Yeah, because the entire thing, that one thing is actually able to power the controller itself. It also has the functionality for powering the entire strip, because you connect. I forgot what it was, like a 12 volt or 5 volt or something like that. There's an adapter that comes with this entire kit. So you hook that into your wall socket, which in my case it's 240 volts, and then that gets stepped down to either 12 volts or 5 volts, and then that is powering this IC, which is then driving the LEDs. And then you also have the remote, which can send which can control the IC to a certain extent. It uses infrared to send the messages, and through the remote you can send different types of codes, different types of messages to get the LED colors and different types of like blinking and stuff like that, different modes. Um, yeah, I need to see if there's a way that I can modify that to do what I'm trying to do. Because yeah, that is actually perfect. I didn't think about that. I did not think about that because we do get those like super cheap. We get those incredibly cheap. We get those. Yeah, I have. There are some places here where we can get those. Though even like online, I can buy those strips, and they would be really cheap. The strip, the driver IC, which is like in a small box kind of thing, and the adapter along with the remote, the entire kit, it comes like it comes as one set. Um, I could use that. I could use that because what I had in mind like initially was just simple, simple LEDs that they're like they're like single color LEDs. I didn't need anything more than that. I actually still don't need anything more than that, to be honest. If I did do the if I did do the LED, hold on. One problem that I would run into, even like the whole reason why I need to modify this driver IC, it would it's mainly because of the words. It's because I'm trying to address like multiple different LEDs, right? Or multiple different chunks of LEDs. That's the main problem that I'm trying to solve. And I don't know if I'll be able to do that with that driver IC. The whole reason for modifying the driver IC is to see if I can actually make it address multiple things. But if I cannot, then I'm back to square one, basically. Yeah, yeah. Though, okay, yeah. So, this what Gemini mentioned here, this thing of multiplexing and charlieplexing, this was kind of an interesting concept to me because it wasn't just addressing multiple LEDs. It turns out it's creating an illusion where it's rapidly blinking all of the LEDs in different ways at different rates to then give you the illusion that this LED is on, that LED is off. And because the ESP32 is able to make these things blink really quick in like a very quick succession, so Gemini mentioned a concept called something of vision, persistive something something. Hold on. Um, just a second. It was right here. Persistence of vision. Persistence of vision. Let me also just look this up. Let me also just look this up. Persistence of vision. Okay, so persistence of vision is the optical illusion where the eye retains the image for a fraction of a second after the actual light stimulus is gone, allowing rapid sequences of still images, like in movies or cartoons, to blend, creating the perception of smooth, continuous motion. This phenomenon, also called visual persistence, is key to animation, film, and devices like zoetropes. I don't know what that is. Making it seem like static pictures are moving. How it works: brief image retention. The visual signal continues in the retina and visual cortex for about 1/10 to 1/15 of a second after the object disappears. Rapid succession. When new images are presented quickly enough, 10 to 12 plus frames per second, The brain overlaps these retained images. Illusion of motion. This blending overlap this blending of overlapping images creates the sensation of fluid movement rather than flickering stills. Okay, so this is the concept that's being used apparently with multiplexing or charlieplexing. Here's the idea that oh, actually, I told you that Gemini had given four ideas, right? One was multiplexing or charlieplexing. The other was using shift registers. The other was using a driver IC, a dedicated LED driver IC, and the other was using addressable LEDs. That's like a whole other concept where you have these LEDs that have circuitry built within them where you're able to control them in various ways. Um, I don't have that. I'm not planning on ordering that. I might maybe at some point because that does seem like an interesting concept to explore. I will have to see how expensive those LEDs are and if I can get cheap knockoff versions of them. If I can, I'll definitely buy them. But for the time being, I really need to work with what I've got. I don't want to have to, buy something, even if it is cheap. I don't want to have to buy something. I have a bunch of components and I want to work with what I've got right now. And keeping in mind what I've got right now, actually, dude, a while back I had ordered a bunch of ICs for various purposes. These were like assorted ICs. I barely even knew what I was ordering at the time. I did look up each of the ICs that were mentioned, and the majority of them turned out to be either EEPROMs, so basically something that you can store data in, or 555 timer ICs. I'm gonna have to see if any of them, if like even a single one of them was a shift register, like in any way. I don't know if I ever ordered a shift register. But if I don't have that, then I can't use it, which is why I'm kind of leaning towards this multiplexing thing, and I kind of want to understand how it works. So, okay, this was the option that was mentioned, and then later on, I asked Gemini to go into more detail with the multiplexing option. Um, Gemini said this is a way to control many LEDs with very few pins by wiring them in a grid and rapidly turning them on and off, so fast that your eyes see them as being on simultaneously as an effect called what? See them as being on simultaneously, an effect called persistence of vision. How it works. For 10 LEDs, you could use a 3 by 4 matrix, which would require 3 plus 4, which is 7 GPIO pins. A more advanced version called charlieplexing can control up to 12 LEDs with just 4 pins. You can set some pins as outputs, and others as inputs, constantly cycling which rows and columns are active. Okay, pros requires no extra chips, just LEDs and current limiting resistors. And it's a fantastic learning exercise in digital logic and programming. Yeah, I think it's definitely going to be an interesting experience programming this thing, considering the fact that I'm programming a grid to create an illusion of state. It's not really that state. Like it is that state being maintained in the background, but like the actual quote unquote rendering of this state is is being done through an illusion. We are flickering lights and relying on this concept of persistence of vision to create the effect of those states. Okay. The cons. The wiring is complex and can be a headache to debug. The code is significantly more complicated. You need to manage timers and constantly refresh the display. The LEDs are not 100% are not on 100% of the time, so their perceived brightness is lower. Okay. Verdict. This is a great, clever trick, but often not worth the complexity for modern projects unless you are extremely constrained by cost and components, which is what I am. I'm extremely constrained by cost and resources. Um, Give me a second. I'm really curious about whether I did ever order a shift register. So I'm just gonna look for that box of ICs that I had, and I'll be back. Hold on. Okay, so looking at my components, I remembered that I'd ordered a bunch of optocouplers. I remember doing a bunch of research on those things a while back, and that was really interesting. That was really interesting because, like, okay, um, at least from what I remember, optocouplers were a good way to isolate two circuits while still being able to control one circuit from another. It's great, especially for digital circuits, but more specifically for digital circuits. You don't want to be using this for um, circuits that demand too much current, that pull too much current, because that current is then going to be going through the optocoupler, and it's not if it's not built for that level of current, then you're probably going to damage the thing. In my case, I built it so I could hack a bunch of electronics that I have. Um, and this was like the simplest way without having to actually join both the circuits together, because when you join both the circuits together, then you have to join their grounds together, and then you have to worry about one side of the circuit accidentally powering the other side, or any sort of like short circuit somewhere, or any like there can be any number of complications when you're not isolating two circuits from each other. There's also the fact that if you are joining two circuits together, you need to really understand how both those circuits work in order to be able to properly join them and confidently join them together, and not worry about, again, something high power powering something low power. Um, just a second. Oh, this is interesting. Apparently, Streamer Awards is tomorrow. Um, yeah, yeah. I don't really care too much about it. It's just kind of like, hey, the thing is there. Let's watch it. Let's see what's going on. Who gets what award? I'm especially interested in the VTuber stuff. Being a VTuber myself. Okay, so I'm looking at the ICs here. Give me a second while I. So the problem is, these are all incredibly small. Fuck me. Why was that so hard to say? These are all really, really small. So I have to like strain to look at each one of them. Okay, I probably shouldn't do this right now because it's gonna strain my eyes, and then I'm gonna have trouble reading. I'll look into it off stream. Um, I should also get like actually I do have a ooh, I have a magnifying glass. I forgot that. I have a magnifying glass that I could have used, but now I'll have to get up and go and get that magnifying glass. So I don't want to do that. Let's just read this. Okay, so the cons are the wiring is complex, the code is complex, the LEDs are not on 100% of the time, so their perceived brightness is lower. Now, their perceived brightness might be lower, but if it's just enough, if it's high enough that it is noticeable in a room that has some lighting. I wouldn't even say it's a well lit room, but it has some lighting. If it's noticeable enough in a room that has some lighting, that's great. That's enough. It should also be an interesting experience. I do wish that I had shift registers now, because this does seem like a. Hold on, let's read the entire thing. So how does this work? Also, how is the shift register gonna power these things? Like, is it the shift register powering it, or is it acting as a switch to power the LEDs through the microcontroller's power? Or let's see. Okay, a shift register is a simple chip that converts serial data sent one bit at a time, into parallel data, multiple bits available at once on different pins. Okay, so at this point it's still digital, right? You send a string of 8 bits from your ESP32 to the shift register using 3 GPIO pins, data, clock, and latch. The shift register catches these bits and puts them on its 8 output pins. A 1 means the pin goes high, and a 0 means the pin goes low. To control your 10 LEDs, you would simply daisy chain 2 shift registers together. You connect the serial out of the first to the serial in of the second. Now you can control 16 outputs while still using 3 GPIO pins. Wait, that's crazy. Hold on. Hold on, dude. I need to look into how much do shift registers cost? Also, wait, let me see if I can open up a new conversation, a new Gemini conversation about this. So Gemini did explain this. I can go back to the conversation if I want to, but okay, I've opened up Gemini here, so I might as well just have a conversation. Have a I might as well just have a conversation with Gemini. Holy shit, dude. Okay, I have a project in mind that requires or that involves powering powering around 10 LEDs independently using an ESP32. In another conversation, you mentioned using a shift register. I would like to understand, hold on, like to understand more about this component and how it works. Also, how do I know that it can put out enough voltage slash current to power an LED? When I'm buying these things, I'm assuming I'm gonna need to look at the power rating, or well, the rating in general, because not power necessarily, the voltage and current rating. Oh, they did actually, hold on, Gemini did mention a specific shift register. Um, there was a 74HC595. This seems really familiar. I wonder if I did actually buy this. Holy shit, dude. If I did buy this, that's going to be crazy for me, because that's like that's a great coincidence. Okay, 74HC595, is that what it was? Yeah, it's a popular 8-bit serial in parallel out shift register. Shift register IC used to expand microcontroller I/O pins, taking a few serial signals, and dude, I've actually been looking for something like this to control a couple of other things. It was this is like the exact kind of thing. This is the exact kind of problem that I was trying to solve in a couple of other projects as well, where it's like, okay, you have a limited number of GPIO pins. What happens when you run out? Like, how do you control other things using one? How do you control multiple things using one pin? Because like usually if it's like a module of some sort, then you have ways to control that. Um, because like within that module itself, they implement the functionality that's similar to this, where it allows you to control multiple things. But then if it's just the pins that you're dealing with, and you're not dealing with a separate module, then like how are you controlling the other components? Turns out shift registers are a necessity here, and they can actually help me use the smaller ESP32s, because at that point the ESP32 is barely going to be taking up any space at all. I can fit it into like a smaller package then. I'll have to see how big the shift register itself is, but yeah. Also, let me see how much this costs on AliExpress. You have a DC 3.3 to 5 volt expansion module shift register 8-bit. Okay, so we're going to open that up. Also, Gemini probably gave a response here. No, there was a different response. Of course, let's break down how a shift register works and how to determine. Okay, this is interesting. I like that. It seems like Gemini is reading the current directory that it's in, and it sees a bunch of files saying Gemini explains so and so. And so now it's kind of adopting this no, no. Um, as great as this is, I don't want Gemini to write the thing for me. Don't write to a file just yet. Uh, type it all out here. I'm or I'll decide when I want to export. So as great as it is that Gemini was willing to write the thing down, I just realized that what if I have like follow-up questions? Because like this is great if I was planning on, immediately taking that MD file and sending it to my other computer so I can view it on stream, which I'm planning on doing that anyways, but like what if I had a thing where I needed to, ask follow-up questions? Okay, you know what? We're gonna learn what a shift register is, how it works, and how we go about finding the right voltage rating. Uh, empty directory. Here we wanna, okay, export this please. So it's gonna, hopefully now it's gonna do the exact same thing that it was doing before. So I'm gonna let it write. Gemini explains shift registers, and now I'm gonna do the, okay, so Gemini explains shift registers, and then we want to send it to this location. Just a second. Okay, okay, okay. All right. Okay, and that is done. Great, awesome. So now that that is done, we can probably open it up in one of these other, yeah, here, Frogmouth. Gemini explains shift registers. Awesome. So that's opening up here. Give me a second. Okay, you know what? Yeah, we are here. So we're gonna read up on shift registers. Actually, before I read, there's a bunch of stuff to read here. So let me take a sip of my energy drink, and let me drink some water as well, and then I'll continue. Actually, then I'll start reading. I also need to see how much these shift registers cost. Holy shit, they're cheap. Holy shit, they are cheap. These things are cheap. Oh, I forgot. Dude, Christmas. Dude, end of the sale. End of the sale. End of the year. End of the year sales. I need to go and spend some money on AliExpress. As stupid as this sounds to say, I need to go and buy some stuff off of there because AliExpress usually has deals at the end of the year. We had the same thing the last year as well. Every at the end of the year, they usually have these deals. There's either Christmas deals or just end of the year deals and sales and stuff. So if you need to buy stuff, head on to that website. If it's stuff that you can that you feel you can actually buy from there. In my case, because I'm buying usually like 95% of the time, I'm buying electronics stuff from there, and it's usually electronic components and electronic modules and microcontrollers and stuff like that. It's more electrical engineering stuff and less electrical appliances, if that makes sense. So for me, it works. Like I'm able to get decent products most of the time. There have been rare occasions where I got something with maybe a pin bent, but the device itself worked. I just had to straighten out the pin. I had one instance where I ordered an MPU 6050, and these are like really these are the devices themselves are small. They are small enough to be one third of your index finger. The devices themselves are already that small. The module itself is that small. The components on them are even smaller. They're like sugar grains or sugar crystals or salt crystals. They're that small. One of the components there, I could see it wasn't soldered properly, because of which there was a bridge between that component and another component. And so I knew if I connect this, it's not gonna work out well. Fortunately, I did order a couple of other MPU 6050s, so I was able to, I will be able to use those whenever I do get to it. But yeah, dude, holy shit! I'm so glad that I remembered that uh, we have the sale season coming up. Hell yeah, dude, I'm excited. I'm excited. I'm gonna look for more of these. So these cost around 700 fills. What I'm looking at here is a module of a shift register. I was expecting just like the IC itself. Actually, dude, why don't I look for the IC? I should look for that, because what I'm looking at here is a module, right? I don't mind getting the IC itself, even if it's like a tiny bit clunky. I don't mind that. Because that'll be easier for me to put into my breadboard. Though, to be fair, the module itself, I would just have to go through the headache of soldering the pins onto it. Um, and once I'm comfortable with like that small, tiny type of soldering, because like these things are getting so small that holy shit, sometimes it's like you need special equipment to solder them. But like if I am able to do it, then I could use the dude. I mean, okay, um, this specific one, 74HC595. Do I absolutely need this? Because if I look at, okay, you guys can't see it because I'm looking at it on another machine, but like this is just an IC that is on a board, on what you would consider a breakout board essentially, because it's on a board. It's an SMD device. It's a surface mount device. It's an SMD component, so it's not through hole. And on that same PCB, there's traces going from each of the pins to all of to like separate holes, and in each of those holes you can put in the header that's provided and then solder that thing on. So then you can like plug that into a um, into a breadboard of some sort. But like, dude, at that point, I might as well just order the through hole version, right? Like, why am I ordering this then? Also, what is this? Digital something. Oh, it's a temperature sensor. That's actually yeah. I do need to order a couple of components for. I forgot what exactly I was calling it, but it's basically I'm trying to approach gardening from a more electrical engineering point of view, where I have sensors set up of various types to give me like the precise measurement of moisture in the soil, precise measurement of humidity, precise measurement of temperature and various other things. And then I can like provide the exact environment. I want to try and do that with at least one plant because I do a lot of gardening, but I do gardening in like a more natural sense. Like I don't get too scientific with it. But in this case, I want to try getting scientific with it. But yeah, okay, hold on. I am looking for 74 what was it? CH595 74CH595. Oh, okay. Yeah, when I look this up, then it doesn't show the SMD version. It shows the dip version. And that's what I'm looking for. That's exactly what I'm looking for. I don't want the SMD version. Yeah, dude, even those are cheap. Those are like, hold on. What does it say? 10 pieces are for like um how do I convert this for you guys to understand? Okay, yeah, dollar 33 cents. So let's say dollar 50. I can get 10 pieces for a dollar 50, and then there's going to be whatever shipping charge there is. With some of them, it's free shipping. So either way, it's going to take like 2 weeks to come. But yeah, dude, I should look into. I know I said at the beginning of the stream that I don't want to have to wait for 2 weeks to, get the thing. But then now that I am going to be ordering stuff off of the website anyways, I might as well throw this in there. I might as well get this because I will be using this for a bunch of other situations. I need to see like how far I can go with the usefulness of this component. I need to study this. Hold on, give me a second. Let me close a bunch of the stuff that's not required so we can, well, I can have a lag-free experience on this machine. Um, yeah, I do need to continue looking into the ESP32 Rust stuff because it seems like a bunch of the books have moved around and so some links are broken. So I'm gonna have to go and find stuff manually, and then I can read the books. Worst case scenario, I can just look for them on GitHub and read the books through GitHub. There might be like a, GitHub readable version. I don't know. Yeah, let me drink some of my energy drink and hydrate a bit, and then I can read this. Okay. All right. So, understanding shift registers for controlling LEDs within ESP32. You're on the right track with, just a second. Right. You're on the right track with using a shift register to control multiple LEDs with just a few pins from your ESP32. Let's dive into what they are, how they work, and how to make sure you're using them correctly. What is a shift register? A shift register is a digital memory circuit that can be used to store and move binary data. The most common type you'll encounter for projects like this are serial in, parallel out shift registers. This means you can send data You can send data to it one bit at a time, serially, and then have all those bits appear on separate output. Dude, I wonder if I wonder actually no. I was okay, so I was about to ask if there's a way, like is it possible that shift registers are implemented within an ESP32 somehow? But then I realized that in the end the output has to come out of like 8 separate pins. So anyways it's going to be 8 separate pins. Like you can't really avoid that. Okay, so though, dude, I'm still interested in checking out that the Charlie plexing idea, because there's this thing about matrices being implemented through hardware, through wiring, that's really interesting to me, because there's there's been a keypad that I've been trying to sort of decode, trying to understand it, basically, trying to understand the way that these buttons are set up and how you can actually use them as one keypad, because the entire thing in total, I think it had, I'm trying to remember if it was, I would have to get up and go look at it, but it was either either three on each side, like 3 by 3 on each side, or 4 by 4, or 3 by 4 on each side. Let's say 3 by 4 on each side. 3 by 4 would be 12, and so then it would be 24 buttons. If it was 3 by 3 on each side, that would be 9 buttons on each side, and so 18 buttons. So this keypad in total, oh, sorry about that. This keypad in total, it had either 18 buttons or 24 buttons or anywhere in between that. Okay, great. Here's the amazing thing. That keypad, it had only 10 wires. Like the circuitry was designed with only 10 wires. Those 10 wires would be connected, and two of those wires I believe were power wires. I don't remember exactly. No, one of them was a power wire, and the other four were, or maybe four, maybe not four. The other nine, either nine of them were VCC and one was ground, or one of them was VCC and nine of them were ground, or something like that. But all these 18 to 24 buttons, they all worked through these 10 wires. You could use this entire set of buttons through these 8 wires. And that was interesting to me. I didn't really understand how that entire addressing system was working, so I was really interested in learning that. That's also why I wanted to learn how to set up a LED matrix, just so I can understand how the addressing scheme is working in that matrix. And that should be simple enough to set up with an ESP32, a couple of LEDs, and a couple of resistors. I have all of that, so that shouldn't be an issue. Um, what was I saying? I forgot what I was saying. But yeah, I want to understand that whole like grid-based wiring system. That's really interesting to me. I guess it's because I've never practically set something like that up, that I don't understand, how that wiring works. So I need to set that thing up practically in order to understand it. Who knows? Maybe we might be able to do that on stream eventually. Okay, this means you can send data to it one bit at a time, serially, and then have all those bits appear on separate output pins at the same time in parallel. The most popular and beginner-friendly shift register is so-and-so. Okay, that's what we just looked up. It's an 8-bit shift register, which means it has 8 outputs, perfect for controlling 8 LEDs. You can even chain multiple shift registers together to control 16, 24, or more LEDs. That's true, actually. Like at that point, so you could then apply the concept of multiplexing on top of these 8 these 8 pins, and then you would be able to control even more. That's interesting. Okay. How does so and so work? Imagine a line of 8 boxes, each capable of holding. Well, okay, I think I kind of understand the concept. I am interested in learning the internal working of it, but I feel like I understand the basic concept. Like you would be using some kind of communication protocol to send these 8 bits to the shift register through these, I don't know, 2 or 3 wires, right? You would be sending the data over to the shift register, and then the shift register would take those 8 bits and split it across these 8 pins. So that's the basic idea, right? Now let's see about the working. I think it's going to explain the communication protocol here. Okay, serial data in. You send a high or a low signal from your ESP32 to the first box in the line. Oh, it's using its analogy, right? You send a bit to the wait. Okay, what is the thing? Imagine a line of boxes, each capable of holding a single bit. All right. Okay, great. You send a bit to the first box in the line, clock. You pulse the clock pin. This shifts the bit in the first box to the second to the third, and so on. The first box is now empty, ready for your next bit. Okay, repeat this process 8 times to fill all the boxes with the bits you want. Okay, I was assuming that it's going to split the data across these 8 pins, but well, technically it's still splitting, but I think my understanding of how it's splitting was wrong. It's sending it to one pin and then to another, then to another, then to another. Okay, latch. You pulse the latch pin. I'm sure there's some protocol or some library or something that's already made that handles this communication for you, but it's good to understand how the thing is working. You pulse the latch pin. This copies the state of the 8 internal boxes to the output pins. Oh, the internal boxes, I mean, the boxes are not the output pins. The boxes are the internal state. Imagine a line of boxes, each capable of holding. So we haven't gotten to the output yet. So I, I guess I wasn't wrong there. So the 8 boxes are the internal state that the shift register is holding, which it then outputs to those 8 pins to kind of show the state. This copies the state of the 8 internal boxes to the output pin to the 8 output pins, Q0 to Q7. The LEDs connected to these pins will now turn on and off according to the bits you sent. Right, this process is very fast, so you can update the state of all 8 LEDs almost instantly. Answering your questions, voltage and current ratings. This is the most critical part of using any component. You need to look at the data sheet. For the specific shift registers you're buying, you can find the data sheet by searching the part number. In the data sheet, you're looking for a few key features under a few key values under absolute maximum ratings and recommended operating conditions. Supply voltage. This is the voltage the chip needs to operate. For so-and-so chip, this is typically in the range of 2 to 6 volts. Since your ESP32 operates at 3.3 volts, you'll power the shift register with the 3.3 volt pin from your ESP32, and it will work. It will work perfectly. Okay. Output current. This tells you how much current a single output pin can safely provide. This is a value that determines if you can power an LED directly. A standard LED typically draws around 20 milliamps to be at full brightness. The data sheet for a typical so-and-so says that the DC output current is plus minus 35 milliamps. This means a single pin can sink or source up to, I need to look into what sink or source means. Oh, does it mean like give out or accept? Maybe, I'm not sure. Sink or source 35 milliamps, which is more than enough for um, a standard 20 milliamp LED. I can see how shift registers would also be used or useful to kind of transfer information from one place to another. In this case, I'm directly powering LEDs with it, but I can see how it could be used to transfer information and sort of control multiple devices through that one shift register. So you would then just be transferring information using the pins. You wouldn't be actually powering an LED with the pin. Technically, you would be not really powering, but like more just transferring information to other devices using these pins. Though I should also look into like the digital and analog. Um, like, do I need to be concerned about, hey, is this like the digital version of it or the analog version of the signal? Is the signal digital or analog? Because like in the end, I think it does come out as analog. Like once it's coming out of the pin, but then I need to see what the difference would be. Anyways, important. You still need a current limiting resistor for each LED. The shift register won't magically limit the current for you. Total VCC ground current. This is the total amount of current that can flow through the entire chip. It's often overlooked. The data sheet might specify this as DC, VCC, or ground current, and give a value like 70 milliamps. Let's do the math. If you have 8 LEDs, each drawing this much, the total current would be that much. That is much greater than 70 um, that the chip is rated for. If you turn all 8 LEDs at full brightness, you will exceed the chip's rating and likely damage it. How to solve the total current problem? You have a few options. If your total current draw is too high, um, lower the lower the LED current use a larger resistor for each LED to reduce the current they draw. For many modern LEDs, 10 milliamps or even 5 milliamps is still plenty bright. Okay, we can do that. I do have bigger LEDs. I can definitely make the LED's brightness lower. I do need to see how how bright they are when the light is on. Okay, for many modern LEDs, it's so and so. Okay, okay. All right, great. Don't turn on all LEDs at once. If your application doesn't require all LEDs to be on at the same time, you might be fine. Or use a transistor or a MOSFET. If you need your LEDs to be bright and on at the same time, the best solution is to not power the LEDs through the shift register. Instead, oh, you use the shift register as a signal for the transistor to then power the LED. How would that circuit even work? Because like, okay, the MOSFET, not the MOSFET. I'm not touching MOSFETs for now. Um, I'm mainly working with BJTs. So the middle pin is your signal, right? You have like one pin into which the current is going to go and the other pin that the current is supposed to come out of. But then while the middle pin doesn't have any signal on it, um, the transistor is not going to allow current to flow through the other two pins. And as soon as you give a signal on this middle pin, that's when the transistor allows current to flow through both of those pins, flow from one pin to another. So in this way, you're able to use the transistor as a sort of electronic switch, right? How would that connection work? So the one of those things would have to go to ground, right? Um, and in one of them, the power is actually no, wait. It's gonna so the input is gonna come from VCC. Yeah, the input is gonna come from VCC. Okay, yeah. Sorry, I lost my train of thought. I was looking at something else. Okay. Um, what was I? Yeah. Okay. So the input would come from directly from VCC. I'm assuming. I'm assuming input would come directly from VCC. Um, and then the signal would come from the shift register pin. I'm really interested in how this circuit would really even work. Yeah, I'm super interested in how this circuit would work. Though I feel like I would be able to set this up easily using the components that I have right now. To test this out, I could use a digital pin to like send a signal to a transistor and then, you know, have that transistor be able to power an LED going through a resistor. The thing is, when you have an extra circuit involved there, then I don't know where you're supposed to be putting the where you're supposed to be pulling VCC from, and whether it matters where you connect ground to. Because like if ground is being connected to, like ground is coming also from the microcontroller, right? So I could connect it to the ESP32's ground. I could also connect it to the shift register's ground because that's also connected to the ESP32. So it's not going to make a difference. But then by that logic, the VCC is going from the ESP32 to the shift register. So then it shouldn't make a difference if it's going, if VCC goes from the shift register to the transistor or if it goes from the ESP32 to the transistor. I need to set up the circuit, dude. I need to set up the circuit to understand if this would work. First, I need to have a conversation with Gemini about this. I definitely need to, yeah, yeah. I need to have a conversation with Gemini about this. Also, a bonus here, I feel like I might be able to represent the circuit that I was trying to, that I'm trying to set up. I might be able to represent it using a dot graph. Maybe. I'm not sure. I'll have to check. Let me see if that's even possible. Yeah, okay. There's a bunch of stuff that I have to do. There's like, holy shit, there's a bunch of learning that I was doing that I've kind of pushed to the side because I keep getting distracted with a bunch of different topics. One topic was the Rust game dev architecture. Another topic was cargo workspaces. I'm currently doing that that lesson with Gemini. Another one was Rust WASM Nano Glue. I think I can close this conversation. I don't think I'm going to be coming back to this, at least not for a while. The at some point I was looking into where even is it? I've like lost. Oh, there was the Lua thing that I was learning as well. I'd made some progress with that, and then I kind of just paused. Um, and then there was also the dot graph. Like, holy shit, there's so much that I have to do. Dude, okay, hold on just a second. Okay, I just noticed the time. So give me a second here. Okay, so there's two people. Okay, so I'm gonna go to this person's stream. So there's someone called Boggs Tavern. They're doing co-working and chores. We're gonna go hang out in their stream. Give me a second. Let me put in the raid command. Okay, so that's gonna be it for today's stream. I have so much reading to do. I have to finish so many things. I need to make a list right now. Yet another list, so I'll remember the stuff that I need to finish. But yeah, dude, that's gonna be it for today's stream. Olax TTV, thank you very much for the follow, and thanks for stopping by and chatting. Anyone else who might have been lurking in the chat, thanks for hanging out. We are on a pretty good streak here. We're on a pretty good roll now. Um, and wait, I forgot. Is it on a roll or on a roll? No, I think it's on a roll. I don't know. I'm gonna have to look that. I can't remember at this point. We're on a pretty good streak, um, and I'm pretty excited about that. We haven't been taking too many days off from streaming, so that's pretty awesome. And on the days where I might be a little too low energy, I might just turn it into like a gaming stream. We might play something on itch.io, and that way I can get a stream in even on the low energy days. So that kind of works out. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.